In this video, we're looking at the derivatives using data worksheet. You can find this PDF linked inside of the description to this video, or also over in Google Calendar. The first page will serve as our notes. This is an example problem that I'll work through, and then the last 3 pages are for your homework. You won't learn any new concepts in this video. All you're doing here is just applying concepts that you already know into a type of word problem that you haven't seen yet. Water is flowing into a tank over a 24-hour period. The amount of water, W of T, in the tank in various times is measured, and the results are given in the table below, where W of T is measured in gallons and T is measured in hours. There are 150 gallons of water in the tank at time T equals 0. It's useful to pay attention to the units here. So W of T is measured in gallons, and T is measured in hours. This first sentence has some hidden meaning to it. Water is flowing into a tank over a 24-hour period. In other words, water is flowing continuously over that 24-hour period. Even though this table only has discrete times, T equals 0, 4, 8, 12, 16, 20, and 24, the water is still flowing at the other times, and it flows nonstop. Part A. Use data from the table to find W of 8. Using appropriate units, explain the meaning of your answer. W of 8 just means that we're sticking 8 inside of the W formula. We're finding how much water is in the tank at 8 hours. If you look in the table, here's T equals 8 hours, and here would be W of 8. That means that W of 8 is equal to 221, and you want to be sure you write the units here, so this is in gallons. So we just want to write a sentence explaining what our answer means. Putting that number into context, that just means that there are 221 gallons of water in the tank at time T equals 8 hours. Part B. Use the data from the table to find W inverse of 257. So let's remember what the inverse function actually means. The inverse of a function means that you're swapping the domain and the range. You're swapping the input and the output. If we're looking for W inverse of 257, that 257 represents the number of gallons. And the answer to this would be the time in which 257 gallons are in the tank. Looking at the table, we can see that 257 gallons are in the tank at time T equals 12. That means that W inverse of 257 would be equal to 12. And the unit for this is in hours. So a sentence for this might read, there are 257 gallons in the tank at time T equals 12 hours. Part C. Use data from the table to find an approximation for W prime of 15. Show the computations that led to your answer, and then using appropriate units, explain the meaning of your answer. We're trying to find W prime of 15. W prime of 15 represents the instantaneous rate of flow at time equals 15. Since all we have is a table of different W of T values for a discrete number of times, we don't have the ability to find the exact value of W prime of 15. You might, however, remember that you could use an AROC to approximate an IROC. That is, the average rate of change can be used to approximate the instantaneous rate of change. So we want to look at the table and figure out where on this table would time equals 15 fall. It would fall right here between time equals 12 and 16. Time equals 12 is the closest to 15 we have that's below 15, and time equals 16 is the closest value we have that's above time equals 15. The best approximation that we can do for the IROC at time equals 15 is to use these two columns in our AROC. Therefore, the best approximation that we can offer for this would be W of 16 minus W of 12 divided by 16 minus 12. The table tells us that W of 16 is equal to 294 and that W of 12 is equal to 257. This would give us 37 divided by 4, which is equal to 9.25 gallons per hour. If you're having trouble figuring out the units, just think about what the numerator represents in the problem. 37 was the number of gallons, and then the denominator 4 represented the number of hours. And then a sentence that explains all this might read, water flowed into the tank at approximately 9.25 gallons per hour at time t equals 15 hours. Part D. Use data from the table to find the average rate of change of W of t over the time period 4 is less than or equal to t is less than or equal to 20 hours. Show the computations that lead to your answer. We're looking for the average rate of change. That's the AROC formula. This is the formula that we just used in the last problem. F of B minus F of A divided by B minus A. In this case, our A would be 4 and our B is 20. So then we're looking for W of 20 minus W of 4 divided by 20 minus 4. Use the table to find the values of W of 20 and W of 4. That gives us 327 minus 184 divided by 20 minus 4. That would equal 8.9375 gallons per hour. Part E. For 0 less than t less than 24, must there be a time t when the tank contains 265 gallons of water? Justify your answer. Notice the time period here is the complete day, 0 to 24 hours. And we're trying to figure out, was there a time in which there were exactly 265 gallons of water in the tank? Remember whenever I mentioned this first sentence here, water is flowing into a tank over a 24-hour period? That meant that water was flowing continuously. W of t is a continuous function. Since W of t is a continuous function, that means that the tank starts off at 150 gallons and then it gradually fills up from there, hitting every single value all the way up until it stops flowing at time equals 24 hours. We only see the values 150, 184, 221, 257, 294, 327, 357. But at some point in this 24-hour period, W of t equaled every single number between 150 and 357. Now, it might be common sense that this is true, but how do we know for sure? Well, there was a theorem that we looked at that guarantees that this has to be true. That theorem is the intermediate value theorem. And remember, anytime that you want to invoke a theorem, you have to make sure that all of the parts of the hypothesis are satisfied. In order to use the intermediate value theorem, you have to have a continuous function over a closed interval. And your intermediate value, the y value, has to be between the two endpoints. So a sentence that explains this might say, yes, the IVT guarantees that the tank contained 265 gallons of water at some time between t equals 0 and t equals 24, since W of t is continuous over that interval and W of 0 is less than 265 is less than W of 24. Part F. A model for the amount of water in the tank is given by A of t is equal to that equation, where A of t is measured in gallons and t is measured in hours. Find A prime of 15. So this problem seems pretty simple. All we have to do is just find the derivative of A. A has that coefficient 1 over 225. I'm just going to leave that coefficient as it is and find the derivative of what's inside the parentheses. The derivative of negative t cubed is negative 3t squared. Derivative of 30t squared is 60t. The derivative of 1800t is 1800. And then the derivative of 33,750 is 0. Now that we know A prime, all we have to do is go through and replace all the t's with 15s. Throwing all that into the calculator, we found an answer of 9 gallons per hour. Finally, Part G says to use the model given in Part F to find the average rate of change of A of t over the time period 4 to 20. Find the average rate of change. That's the AROC formula. AROC is equal to F of B minus F of A over B minus A. This would be F of 20 minus F of 4 over 20 minus 4. This equation is quite long, so the best way to calculate A of 20 and A of 4 is to define this equation inside of Desmos or your graphing calculator, and then just feed it different values of t. To keep things simple, I replaced all of the t's with x's. Now that we've defined a of x inside of Desmos, in a new cell, we can just tell it to solve a of 20 minus a of 4 divided by 20 minus 4. And that answer is 8.996. The units for this would be gallons per hour.